Welcome back to the tutorial course on Android app development. In this section, we will discuss layouts. A layout defines a visual structure for a user interface, such as the UI or for an activity or app widget. A layout can be created in two ways. A layout can be created either at runtime or you can declare your layout in a simple XML file. The Android framework gives you the flexibility to use either or both of these methods for declaring and managing your application's UI. There are several advantages of declaring your UI elements in the XML file. This method enables you to separate the presentation of your application from the code that controls the application's behavior. Since the UI descriptions are external to the application code, you can modify the descriptions without having to modify the source code and recompile. For example, you can create XML layouts for different screen orientations, different device screen sizes, and different languages. You can modify the XML file alone and easily recompile it. Additionally, declaring the layout in XML makes it easier to visualize the structure of your UI, so it's easier to debug errors. In general, the XML vocabulary for declaring UI elements closely follows the structure and naming of the classes and methods, where element names correspond to class names and attribute names correspond to methods. Let's look at a sample XML file. The element name text view is the class name, and the attribute names such as Android ID, layout width, layout height, and text correspond to the methods. You can see that in the XML file, we are giving the value wrap content to layout width and layout height. Each layout file must contain exactly one root element, which must be view or view group object. Once you've defined the root element, you can add additional layout objects or widgets as child elements to gradually build a view hierarchy that defines your layout. That is, you can add child elements within the root element to define the layout. For example, here is an XML layout that uses a vertical linear layout to hold a text view and a button. Linear layout is a view group. This is the root element, and within the linear layout view group, we have added two views, a text view and a button. Save this file with a .xml extension within the res/layout/directory and then compile. For example, you can save this file as myfirstfile.xml. A layout resource defines the architecture for the UI in an activity or component of a UI. The file location for an XML file is res/layout/filename.xml. The file name will be used as the resource ID. In our example, the file name is myfirstfile.xml, and this name will be used as the resource ID. When you compile your application, each XML layout file is compiled into a view resource. You should load the layout resource from your application code in your activity.onCreate callback implementation. In this sample code, you can notice that when the application is loading, it is going to an activity. The first method that will be called is the onCreate activity. This automatically calls the onCreate method. Inside that method, we have a function called setContentView, and in the setContentView, we are giving an argument in syntax r.layout.xml file name. In this example, the XML file name is main_layout. To load this XML file, give the function as setContentView and the argument as r.layout.main_layout. Likewise, we can load an XML file from the resource folder. Every view and view group object supports its own variety of XML attributes. Some attributes are specific to a view object. For example, text view object supports the text size attribute. However, we need to remember that these attributes are also inherited by any view object that may extend this class. Some attributes are common to all view objects because they are inherited from the root view class. For example, the ID attribute. All view objects should have an ID to uniquely identify that particular view object within the tree. When the application is compiled, this ID is referenced as an integer, but the ID is typically assigned in the layout XML file as a string in the ID attribute. This is an XML attribute common to all Vue objects and you will use it very often. ID is used commonly for all the Vue objects and this object is widely used within the application. The syntax for an ID inside an XML tag is Android ID equals @+ID/my_button. The @ symbol at the beginning of the string indicates that the XML parser should parse and expand the rest of the ID string and identify it as an ID source. The +symbol means that this is a new resource name that must be created and added to our resources in the r.java file. This is automatically done by the Android framework. If we are giving as ID with this syntax, the framework itself understands that the XML parser should parse this ID with its ID resource name and the plus and understands that this is a new resource and adds that resource into the r.java file. A common pattern to create views and reference them from the application. 1. Define a Vue widget in the layout file and assign a unique ID to it. In this example, we have given a view and have given a button object. We have set the ID, layout width, height, and text for the button object. We have given a unique ID, my_button, to this button object. 2. Then, create an instance of the Vue object and capture it from the layout, typically in the onCreate method. This indicates how we can access this button object in the application code. In this example, we have created a button object and used the find view by ID. Thus, we are accessing the button with the specific button ID name r.id ID name. XML layout attributes named layout_something define layout parameters for the view that are appropriate for the view group in which it resides. Let us look at the sample layout for an application structure. Notice that the parent view group defines the layout parameters for each child view, including the child view group. Here, one relative layout and two views are derived from the linear layout. These will have the parameters of that linear layout. Three views are derived from the relative layout. These three views will have the parameters of the relative layout. The properties of the linear and relative layouts are different. We will get the corresponding parameters of the parent. The three views at the bottom will get the parameters of the relative layout, which is their parent. The relative layout and the other two views will get the parameters of the linear layout. Let us understand some common layouts that are used in app development. Linear layout. A layout that organizes its children into a single horizontal or vertical orientation. If the length of the window exceeds the length of the screen, the Android framework will automatically create a scroll bar within the linear layout. You can notice in the sample, children are arranged horizontally. Relative layout enables you to specify the location of child objects relative to each other. For example, child A to the left of child B, or to the parent, aligned to the top of the parent. We are positioning one child relative to the parent or another child. Here, notice that child 1 is on top of child 2 and 3. Child 2 is on the left of child 3, and child 3 is on the right of the second and below the first one. Web view, used to display web pages. When the content for your layout is dynamic or is not predetermined, you can use a layout that subclasses adapter view to populate the layout with views at runtime. If we can't identify the number of views used or if the number of values are not predetermined because some of the values are populated from a database or from other files, then we use views derived from adapter view. Layouts that are supported by an adapter are the list view and the grid view. The list view displays a single column list and the grid view displays a scrolling grid of rows and columns. This brings us to the end of our discussion on layouts.